Hello everybody, Brad the Guitarologist here. In today's video we're going to look at an amplifier that I've actually demonstrated on my channel before but never quite explored fully or tore down. The opportunity to do this comes courtesy of the new owner accidentally knocking it over and breaking off the power switch. So we're definitely going to replace the power switch. He said it also won't he thinks he fixed the power switch and it still won't come on or something like that. But we're going to take a look at that. But I wanted to show this amp off mainly because this thing has a really seriously good crunch tone. But interestingly, it features 12AY7 preamp tubes rather than the more ubiquitous 12AX7 higher gain preamp tube. So we're going to kind of explore this a little bit and just look at the schematic. We're going to open it up, take a look at the guts, and see if we can determine a little bit about what makes this thing tick. So if that sounds like something you'd be interested in, stick around. Okay, the Lectrolab R500 is the name of this amp. Lectrolab was a company in Chicago. They're also known as Sound Projects Incorporated. They actually did a lot of contract work for other Chicago catalog firms and never put their name on all of their products, so you don't really know you have Electrolab a lot of the time unless you do some research. But on this particular one, they did put their name on it, and we're going to take a look at it. It features two channels with independent volumes. We have a channel 1 volume, a channel 2 volume. We have two inputs for channel 1, one input for channel 2, and we have a tone knob that's common to both. We also have a dual light, a on-off switch, and a fuse, which is supposed to be 2 amp, and we will go ahead and check that now. And it is correct. It is a 2 amp fuse. I like to go ahead and check these things while I'm thinking about it. And that thing feels a little bit loose too, so we're going to think about that as possibly being broken as well. That thing feels a bit loose to me. But yeah, like I was saying, this thing has 12AY7s, two of those. It also has two 6V6s, a 5Y3 rectifier, and it has a 12-inch speaker. In this case, it's a Jensen. But let's take the back door off and get a little closer look. Okay, here we are with the back panel off, and we find a handy-dandy schematic taped to the back, which is really nice. It's also evident that we have the masonite, the requisite Chicago masonite cabinet. The whole thing is, in fact, it's actually not masonite. This is like a paper board of some kind. I mean, it's basically like glorified cardboard, but it's very similar to kind of some of the stuff they were using in Danelectro amps back in the 1950s, which is the era this is also from. I think this is a 1958 or so amplifier. But you can see here the covering that they're using is basically one step kind of above paper. It's really thin stuff, not all that durable. It's amazing that this thing has survived even as long as it has, completely intact, given the fact that it's made of glorified cardboard and just some kind of paper covering. But at any rate, all the cabinetry aside, the circuitry is what we're really here for and what we're really interested in. Let's take a look at the schematic for a second. We will see our 12AY7s. We have two of those. Of course, 12AY7s are they are dual triode tubes. And let me get a pointer here. You can see here's our first two inputs, and here's our third input. Our third input goes over to pin 2, which is the grid of one of these triodes, and The other two go to pin 7, which is the other grid. If we look closely here, here's one of the plates. It's kind of hard to see because the plate comes up and then they've got the schematic running the plate down to here. So this is the channel 2 plate, and here is its coupling capacitor going to its own volume control, and then the two channels get mixed in after that volume control. So they have an independent half of a 12AY7 that each channel uses here. So really you could jumper these channels. You could come out of this with a jumper cable and come over here to this channel and run both of these in parallel for that first upfront stage if you wanted to, and get even more gain out of this. I don't know if you'd find that necessary or not, because this thing really does crunch up, and I'll demonstrate it again later, and also link to the other video that I made at the end of this video, so stick around for that. We again have dual 6v6s, but let's see how these are hooked up. I'm not sure if they're push-pull or not. We do have a common cathode resistor here, R19, 250 ohms, 5-watt resistor, but we have no bypass capacitor, interestingly enough. With a 12-inch speaker and two 6v6s, you would kind of think that maybe they would have included one. We're going to see if it was modified at some point, and maybe somebody else did add one. But it looks to me like, let's see, here are our coupling capacitors. It looks like we have a The phase inverter looks to me like something called a floating paraphase inverter, which has some characteristics. You can see here the signal that gets mixed together comes into this stage here. So this is, we can call this the positive phase, which goes directly to this 6v6 through your coupling cap. But then it comes down here, and interestingly, on a side note, here's the tone control off over here. So that's a strange place for a tone control, to put it right there in that area. But after we go through an R16 resistor, which is a 470k ohm resistor here, then we get our phase inversion as it comes through. This grid, our cathodes share a bias resistor on both halves of this tube. Coming out of the plate, this will be the reverse phase of what was up here going to this tube, then goes to our other 6v6 through this coupling capacitor. Here's our grid leak resistor, which is also a 470k ohm on R18, but R17 is a 22k, and that is the grid leak resistor for this half of the paraphase inverter. So that's the grid leak resistor for that. So that's why that's there. So yeah, kind of an interesting phase inverter. You don't really see a whole lot. At least I think that's what I'm looking at here. If I'm wrong, somebody please correct me, but that looks like a floating paraphase inverter to me, according to my reading. But yeah, just an interesting little amp, and we're going to delve into this. We're going to take the chassis out and look. Obviously we're going to fix it, but we're going to look at it while we're doing that, and we're also going to demo this thing. And I think you'll understand then why I'm kind of so up on these Lectrolabs. I mean, they're right up there. As far as I'm concerned, they're right up there with some of the Dan Electros as far as crunch tones, and it's just so strange that they have two 12AY7s and so much crunch. But I'll show you what I mean. But let's first get this thing open. Here's a quick shot of the tubes, and you can see that they're labeled 5Y3, a couple 6V6s, and there's our 12 AY7s. Here's a Jensen. This thing, the Jensen that's in here is a C12Q. We'll get a little better look at that. It's kind of hard to read from here, but it is down there, C12Q. Not sure on the date code quite yet, but you know, as mentioned, this thing fell, and our power switch broke, and it's kind of just, it's messed up. You can tell that, and this may also be messed up. I'm not sure. It seems a little bit loose. But another thing that's definitely loose is this speaker wire. It's broken off. I think what may have happened is this chassis may have, you know, taken a bit of a bang, and then this terminal that's in there that holds the speaker wires got bent, maybe against the speaker housing. So that might be why it's not getting any kind of signal to the speaker. Alright, here we are inside the chassis, and first thing I notice, obviously we're going to have to replace this switch anyway, but our power cord wiring is not really correct, so I'm going to go ahead and correct that while we are in here. We also have a lot of upgraded components. Here is our bias resistor, and someone has actually added a bypass capacitor of 10 microfarad, which is probably a good idea. All these coupling caps are replaced. This is a tone cap, which looks replaced, but I don't know. Looks replaced to me. It looks a little more modern than 1958. Got a couple of resistors here that I'm sure are replacements. I'm not sure about these resistors. Those power resistors may have been replaced also. This big orange cap is a replacement, I'm sure. That's a 0.05. So yeah, I mean, you know, somebody's basically come in here and at some point and rewire this basically. Let's look at the transformers here. Yeah, that's 1958. These are all 1958, 46th week here. So these are original. That's original. That's the output transformer. The cap can, I'm sure, is original as well. At least it looks it. But capacitors I don't think is a problem. All we're going to do basically today is replace this switch, rewire this, reattach that cord going to the speaker, and give this thing a listen. We really are taking this opportunity because I want to show you how awesome this thing sounds. So let's go ahead and do the work to it and then give it a listen. Okay, let's test this little firecracker out. In order to do the test, I'm going to use an early 1980s Gibson Corvus. This is a 1983. You might remember I've previously demonstrated the Gibson Futura. Well, the same customer brought me his Corvus to be set up as well, so good as time as any to show this thing off too, so why not? So yeah, that's a late 1950s Lectrolab R500. Hope you guys have enjoyed this video. If you don't mind, click the subscribe button below to get future videos like this. And for now, y'all take care.